Here's a little quick summation. I'm going to talk about cracks again. The cracks that appeared after they post tension number 2 and number 11. And also that appeared in number 10 and number 3, I believe. Let me think about this. Let me run this past you. I want to give you guys the transverse cables again. I already talked to you about transverse cables, that there were only one in the canopy on each side and one in the deck each side before they post tension the 11 and number 1. But I want to give you, and I talk about the differences in the base. Over here is 3-foot base that number 1 sits on top of the deck, whereas number 12 sits off the deck. It's got a ton of steel in it, not literally a ton of steel. It has figuratively a ton of steel in it, and this side, number 12, has the bar B sitting in a blister. Well, we talked about that. Now I'm going to hit this transverse cables for you again and show you a weird profile that I, well, let me tell you what I'm going to show you. I'm going to show that the longitudinal cables, longitudinal cables come this direction, but then they, at this point, the trumpeted area turns down. All right, well, that's fair enough. On the canopy, the trumpet area turns up just ever so much. So I wonder how much of their torque, of their elongation, etc., was lost in wobble, in the friction of that radius here and here. But oddly, one is turning up, creating a force that would be a lifting force, and this one is turned down. I'll show it to you. We're creating a force that would be pushing downwards. Very interesting. I just want to show it to you, and how much of that is lost in their. Let me back out, and let me pause, and let me get you the step forward real quick. So this is in the deck. This is these guys to your left here, where the mouse is, D1 through D6. These are transverse cables, D1 through D6, and they're not in the same elevation either, but they do have concrete encapsulating them around the exterior. Now here is the profile of it, looking at the side of the structure. You would see, for example, this would be like, you can pick either one of those, but D1. The profile is of such, the trumpet, this area here, and right outside the trumpet, 12-foot radius right here is what they use to turn and make the post-tension ducts and tendons go pretty much parallel to the deck, inside the deck. But at this point, so the torque action, you can imagine if I were to start torquing here, it would have a downward force right here, a downward force right there. And some of that friction, etc., is referred to as wobble. You guys can Google wobble, W-O-B-B-L-E. That is in the deck area. Oddly, in the canopy area, it goes the other direction. Instead of pulling down, they turn and it goes up. So here again is the other side of, this is base of 12, and that's 11. And this is sticking out into a blister. I've found 10.5 inches up to 12 inches and some change. This is very interesting. The measurements now we have, you can find here at 11. Let me pause. 11 3/8, I believe. So I'll get back to the top canopy in just a moment. I wanted to show you this. This is what I call A, and that's B. Reference to the drawings, they do say A and B, but they don't identify besides the length being 2 inches different approximately. Notice how A, as I call A, goes through the floor, the decking right here. That would be this guy right here. So we have a measurement we can use in this drawing now. From this point to this point is 2 foot 4.5 inches, an additional 2 foot 2 3/4 inch to the outside, including the blister part of the decking. 2 foot 6 1/4 inch to the face of that roughly Well, that's a tough roughly right about the top part of the that plate there. So that plate's here. So right about the top part there would be the measurement that we're looking at, 2 foot, 6 1/4 inch, and that would stick. If this is 6, the balance is 6 1/2 inches. Apparently 6 1/2 inches. So a total of I think just 10 1/2. So it's like 4 inches. So we got 2 foot. 2 foot 2 1/4 inch to the face of here to there, roughly plus or minus an inch or two. So the face of this guy, not where it's broken and spalled out, but the general design was from here to there, 2 foot 2 inches. Did I say 2 foot 2 1/4 inches? 2 foot 2 1/4 inches from there to there. The balance being the blister that's missing here. As I stated why. The pipe's clearly going through it. There's nothing there. And I state this, the shear from the load of 12 coming down here and here. Not the magical punch out with the material still there. Magical punch out that it's referred to as, right? Now, let's get to the canopy. Well, let me give you a couple more details of that. Let you pause that to take a screenshot if you like. So that's from there to there. All right, you got it. That is the decking, and this would be the blister part sticking out the back of 12. As you can see, you could say that all of it sticking out of number B is sticking out in the blister, and the deck is on its own. The other part of members. So let's scroll right down to the canopy, and I'll show you that other trumpet of the longitudinal cable, how they go not down like this as in the deck, but they go the other way, up like this. Here's the canopy here. Here it is here. So this goes up. So the torque action or the forces as this cranks up has a lifting effect. Of the tendons. Now the tendons are being being placed in a duct, and when you go to crank down on them, if this doesn't give you a clear path, if it touches the walls, and there's your friction, and your behavior changes. So this is very interesting. Very interesting. The torque effect of this has an upwards lift. And the base, the deck, has a downwards lift. Put those two together, what do you have? You've got two forces working against each other to some degree at their diaphragm and column areas. I find that very, very interesting. Why didn't they both face the same direction and work with each other? Well, this is the top of there again. This would be the top of 12, let's call it. This would put that more forces going down if it has that torque effect. It would be inwards, but that puts the 12 and 1 more supporting. And this is the back span, as you can see, C2 and C1 is very. That's the other span. Finally, I'm going to end it with. Well, I already talked to you guys about the transverse cables in another video, I think, about how they're not over top of over the diaphragms. That they're over the deck only. That's the canopy, and if you take note of the canopy, it jogs out. But yet, all the images online show the ductwork inside the nodal areas, inside these blisters they call them. So I find that there's some serious deviation going on from these 2017 stamped plans. I mean that's hugely significant. So you see that the torque action, again, would be a turn here and a turn here. So you imagine trying to pull through there. It's going to have some friction here and friction there, and opposite on this end too, down here when it's being pulled tight. And that is C1s. Correction, C2s. C2, sorry. So that's very interesting. But let's look at the scale of what they're doing. Main deck span D1, and that's the one that has the least amount of tendons, 12, compared to 19 with the rest of them. D1 is the one that they tension first before they then apply the load of C of number 2 and number 11. But notice that dead ends. Each dead end is going to have dead end rather is going to have a 489 kips. That's the south end of the structure. 489,000 pounds of force, basically, and down on the in the north end, you're going to do 471. There's a huge difference. The north side of the structure and the south side of the structure is nothing the same. They're not the same. They're not essentially the same, as the report may say. Let me pause it and show you again. Looking at the OSHA report, it's stating clearly here that the magnitude of the post-tensioning forces are adopted from the post-tensioning schedule prepared by FIG Engineering, Inc., which we know as FIG. So as I proceed here, for clarity, this is the face of the back of the diaphragm. This is the blister bar reinforcement you're looking at here. All of these bars, they stick outside the face. And the only thing that was outside the face in this area by the drain pipe was the blister of the diaphragm. The 10 inches or plus or minus. I'm sorry, plus. I won't say minus on that one. But probably no more than 1 foot 3 inches. So 12 to 10.6 to 10 and a half inches to 1 foot 2, 1 foot 3, right about there is the max that stuck out. But apparently it's not that much. And you see the reinforcement as I stated. There's the face of that A, as I spoke to a moment ago. And here's even a better image of it. That measurement that we saw a moment ago, it said 2 foot, 4 inches. It was right about to there, just for clarity for you guys. Here's the face I was referring to, and those are the bars, the uprights, I believe, were inside that blister, the width of this guy here. And anybody with some common knowledge would clearly see a bunch of shear cracks going on here. And the shear cracks are from a downward loading, not a push out, because that push out didn't even exist at that time. Number 11 was already fractured up and had gaps between it, not compressive forces. So clearly this is a downward force, and the action of the deck canopy deck, I guess I was trying to say, but that's ambiguous. So the canopy pulling it back over gave it the other effect, the other rising effect. Further evidence for you is data for you. As 12 is pushing down, there is rebar here, and since 12 is pushing down, it equally loads this reinforcement across here, and you get that spalling as you see here all the way across. But it's a beautiful 45 from here to here, which would be the downward force of 12. These are the post-tension ducts I referred to as. We clearly are standing, they're underneath the blister. They're not way out there as a drawing show, but they're way out. They're way inside the blister zone, these ducts. I find that very discerning. I'd like to see some resolution to that. This is some great, I'm going to call this evidential material, because you can count the threads in the original image, I'm sure, based off of this location here, and you can determine how much they elongated this by how much force it was by the placement of the amount of threads left here, and also the amount of threads left on the other end of this top member. So this is very important to see that, because the report states that they finished. Well, they say multiple things. First, they finished it, and then they didn't finish it. They can't make up their mind. They just finished it, and then they were working on the last one to finish. They're all over the place, but this is B. Apparently, this is B, and we can see the location, the final thread count of this. So this is the spray part that they spray off to then start their elongation and check. But that's a verifiable piece of evidence. So the sixth person was okay. VSL employees began to retension the bars around noon and reportedly followed instructions. They retention the bars 50 kips at a time. They had retention the upper bar at the desired tension of 280 kips and were at the lower bar at their last cycle to complete 280 kips when the incurred incident occurred. They were at the last cycle, so they were at the bar had 230 kips on it minimum, and then they were bringing it up to 280, so reportedly part of this document. Other places they state that they finished it inside this diagram. The de-stressing of post-tension bars in diagonal 2 and 11 was completed on March 10th, 2018 at approximately 6 p.m. This is March 10th. De-stressing. The cracks appeared then thereafter. No shims. I think it's noteworthy to point this out to you guys. So D1 are the those tendons, right? The longitudinal tendons across the back of the deck that I just spoke of. They're the ones that got done first. D1s are left and right. Left was on January 16th, right? D1. It took them, well, I don't know the January 16th, but they didn't do it again until maybe the weekend, right? Maybe they came, and then they came back on the 23rd. So D1, left and right. They have D1R and D1L. They've got it as 19 strands here. D1L is 12 strands, not 19. So I don't know what's wrong with this report there. And then down here, canopy. Canopy right here. C2 and C2 left, C2 right. Both on that day, 19 strands, they state. So going here, so canopy, main span canopy, C2, 12 strands, 12 by 6. So this report is, it's got some major issues there. Was it 19 strands or was it 12 strands? And then we come down into, this is telling not about the report, but in general. It's 280 kips on the bars, but we have 2A and 2B. So that's on the far end of the deck. On January 13th, 2B was done. It was, look how many days later, not until January 30th, did they do the 2A. And that same day, they finished off 11A and 11B. That is an interesting break. What happened with these days? What happened with those days? So I'll end it with this again. Why is everyone trying to keep comparing the south end with the north end? It's just ridiculous. They're not the same. And here it is in the report. Diaphragm 2 reinforcements. On the north side over the pylon, that's the failed side. The bridge was supported over 2 foot wide and 4 foot deep beam identified as diaphragm 2. At the nodal point, it was 2 foot 10 inches wide for a width of 1 foot 9 due to the column 12 intersecting the diaphragm 2. So the depth of the diaphragm varied due to the slope of the deck. It was 4 foot deep over the support of the pylon. You see that it's a huge difference. The other end was 3 foot, not 2 foot. It was 3 foot wide and not 2 foot wide. They both were 4 foot tall. That's an even wash. That this had a blister sticking out of it is also left off. That it stuck out. The diaphragm sat over the bearings, consisting of 4 hard plastic pads. Well, the diaphragm, part of the diaphragm did. The primary reinforcements were 6 rows of, well, we'll move on from that. So, but what he states further down here is, right below it, Diaphragm 1, similar diaphragm 2, except for it was 3 foot 6 inches wide, about 4 foot deep. Nowhere similar. Nothing like it. Not similar, no. That's quite a trigger for me. That's quite a trigger for me. Let's go ahead and terminate the video with that. I think I put us up to speed with everything. I wanted to show you the differences of the two ends again. So anybody tries to compare the two ends, you guys can say, you can tell them they're on drugs. You know, they have no ability to, their logic sucks and they can't understand what they're looking at. So it appears that the diaphragm on the south end, south end, sat on these concrete bearing seats. And that was going to be it. No shimming required. See, no shimming was required here. On the other end, yes. Instead of the expansion joint that was going to go there, etc. At that bent. So, no. I think it was at the bent, the expansion joint. Somewhere down here. Possibly up in the deck area also. Alright, terminating video. Thanks for watching. I got to jump back in. Temporary supports of main span selection shell. This is shell. Stay in the middle of the cross section during SMPT transportation. They were supposed to remain in there per the 2017 stamp plans right here. And that is after 2 and 11 was already there, because it states in these same plans, do not detention 2 and 11 until the structures, the main span is complete. And that's when I argued with you guys, well, it can't be complete until it's complete, which means everything. So therefore, 2 and 11 would be done last, and then I argued, how do you get the around those pipes? And it looks like you could squeak past those pipes. But therein lies the problem right there again. For summation of it again, is that number 2 and 11 was not done. Pausing. It was supported in the staging area with many supports underneath of the diaphragm over here. And when they changed it around to support it here, it's now been supported on little plastic shims. Little plastic shimmies. And the little plastic shimmies are just right there lying on the deck. These little plastic shims. Whereas when they were moving the structure, here's a screenshot now snatched up. You can see that in the staging area, this is the back of the, that's that little blister I talked about with the pipe sticking out, the drain pipe. That's a shadow of it. So the light's coming from this direction. Look under the underside of this. You can see how it was fully supported in multiple locations, looking at these imprints, these shadow marks, if you will, these fingerprints of the materials that were holding it up when it was in the staging area. And then along comes, they change it to just these couple of contact points. Interesting though, here's a port here and here. It's multiple locations supporting it. And there's no grout at this point outside here. And the light could have blown it out. I can't tell what's going on there. So what I do live with you guys is I do this. I go to that. Hopefully it loads. Okay, good. So it loaded. And not ready for that one yet. You guys will get to that. Here we go. So then I go to, then I'm in this one. I'll try to bring up the exposure under here, see if we can identify things a little differently. Okay, now let's go for contrast. So that shows itself a lot more clean coming across there. But that's an interesting exposure. That's an interesting exposure for sure. It's a rebar. Okay, so nothing interesting about that. And one more time, let's go blast out. You'd be surprised at blasting it out, what you'll get. And we'll go to the other direction. I was trying to see what was underneath here, if anything at all. And it appears I can't find anything under. Yeah, there's a different, I like that tone. I can't find any support underneath that blister. So in the staging area, apparently They didn't have anything there besides the loads of the tension applied to the bar in number B, the top bar. So terminating the video, but you guys now see that there's a total difference between these two ends, that the clamp force on this end was much greater than the clamp force down this end per the specifications for post-tensioning. So it was weaker down, inherently weaker down this end than the far left, than the south end. That they did not follow their plans of supports, etc. And terminating video. I hope you enjoyed it.